It's Mark. I'm a physio, hate more physio. The paper I'm going to talk about today is a paper from 1996 by an electronics engineer called Adrian Thompson. The paper's called An Evolved Circuit, Intrinsic in Silicon, Entwined with Physics. So it comes to the world of electronic engineering. And what it studied was evolution, an evolutionary hardware. What they did was they took a reprogrammable chip which had a series of programmable logic gates within it. It took a 10 by 10 square within that, and it attempted to, through evolution, solve a problem. The problem it was trying to solve was, what was take two inputs, an input of like 100 hertz and 1000 hertz, and try and discern between those two signals and then produce an output dependent on that. And they solved the problem. It took about 4,000 iterations, and that was great. So evolution, has been mapped elsewhere, and it can be done on computers and things like that. So it's not too surprising that they solved it. What was surprising was the solution and the shape that the solution took. When they looked at the actual logic gates, they could find no logical order or no reason for the sequence of gates that had been chosen. Even more than that, they found that whenever they took the program and put it elsewhere, it didn't work. So if they took it to a different part of the chip, it didn't work. And if they removed it and moved it around and tried it on different chips, it still didn't work. And what it turned out that had happened was that the program itself and the evolution itself had taken advantage of imperfections in the hardware and had evolved a solution based on the specific constraints of the substrate in which it was programmed at that time, and allowed it to build this really non-series solution. So it's not an algorithmic solution to what we would perceive to be an algorithmic problem. If we sat down to try and work out an input and an output, we would sit and we would solve that in series, and it done this in a different way. And the reason why I find this is a great paper is because it really shows the nature of evolution itself, and then also the nature of complexity. So with evolution, we often ask why is this like this? So we look at somebody who's in chronic pain and we think, well, why is their nervous system generating this pain? Now, this may be the wrong question to ask, and the reason why it's the wrong question possibly to ask is that it may be that the solution that is being derived to solve was based on a particular substrate at that time, particular inputs and outputs in a particular environment, may well have fallen outside of that environment or that substrate or those inputs and outputs. And it may be that evolutionary answer is unstable once it goes beyond those parameters. Now, some evolutionary solutions may well be very stable and might have a broad range of parameters within which they might work, and some may not. Some might be quite small, and we may not actually know which interactions of those parameters. It may be subtle effects that we are not privy to that may cause these changes. And it really helped me to get my head around the complexity of complexity. So I hope that I find that useful. It's really worth a read, and I'll post the links below if you have a look through the paper, but I'll also post a synopsis from my website as well, which kind of goes through and kind of sensationalizes it a little bit, but it's a nice thing to read. Hope that was useful. Okay, thank you very much. Bye now.